Hey guys, welcome back, and today we're going to be looking at 2.7.1, which is parent functions, and we're going to be looking at translations today, and we kind of have this watermark here, this huge watermark. My Smart Notebook subscription is out and the school needs to renew it, so we kind of have to deal with this for a little bit. Hopefully I can get rid of that soon. But to start, I just have, do we remember what the graph f of x equals x squared looks like? And if we remember, if we just sketch a graph here, x squared is just going to kind of swoop down and curve right back up like that. And that's just the graph that we've been working with quadratics, right? Quadratic meaning something with x squared, and they've been making this parabola shape. If we remember those words, it's been making this parabola shape, this U shape, and that's just a quick reminder for that. And so a parent graph is just the graph of a relatively simple function. And when I say simple function, I just mean something that looks somewhat nice and is basic, right? Like we don't have any extra things going on. So f of x equals x squared would be a good example of a parent function because we have this nice graph here. And 0, 0 is a nice point. It looks pretty symmetrical, things like that. We don't have like +5 or anything in parentheses or anything too crazy going on, right? It's just f of x equals x squared. So that would be a good parent graph. Some other ones that you probably have seen, maybe should recognize, probably don't remember. It's okay if you don't. But we have the graph of f of x equals the absolute value of x. Remember, absolute value just means take whatever is inside and make it positive. So if we kind of pretended that we didn't have the absolute value for a second, we'd have f of x equals x, right? Which is just your basic line, and then we would start going negative. But since we have this absolute value just says take anything that's negative and just make it positive. So that's why we get this little V shape. So that's the basic graph of f equals the absolute value of x, right? And again, looks pretty simple, symmetrical. It's got this nice point 0, 0. So that's a good parent graph. F of x equals the square root of x. So this one's kind of harder to visualize, right? It's kind of almost a counter to x squared because x squared would start here and then go up really fast, right? This one is still going up, just much slower, right? Because we're taking this square root, and so that's what the graph of that looks like. Again, a good parent graph it's pretty simple, right? You're just kind of going out to the right. It almost looks like we took a parabola and just turned it sideways, right? And we're just missing that because we can't take the square root of negative numbers. And that makes kind of sense, right? That we've kind of turned a parabola on its side if we've taken the square root. And then the last one that we're going to really look at is an exponential, which again you've probably seen before. Maybe you don't remember it's an exponential, but when we have something to the power of x, then we get this super thing where we get really close to 0, but we go up forever, right? And it kind of makes sense that we shoot up really fast, right? Because the bigger x is, the higher to a power is, and we know that things to a power get big really fast, right? And then if you remember our power rules, if we get smaller and smaller, we don't pass 0, right? Because like for example, if we had if x was -3, right? If we had 2 to the -3, we might not remember what this means, but what this really means is it means 1 over 2 to the third. That's what that means, right? Which would be 1 over 2 times 2, which is 4, 1/8. So we just get smaller. And you can think as the negative number gets bigger, right? As we get like -4, -5, -6, the denominator is just going to get bigger, which is just going to get it closer and closer to 0. But, we're never going to hit 0 or pass it. So that graph kind of makes sense as well. And then for this, just remember, this is a word that I think we should have seen before, translation. But if you haven't, a translation is just when you move or slide something so there's no rotating or resizing, making it bigger or smaller or anything. It's literally just taking it and sliding it, moving it around. So let's just play around with a couple translations. Let's see what happens to the graph of f of x equals x squared when we add or subtract to that. And for this, I'm going to go to Desmos here, and here, here's our parent graph, or just f of x equals x squared, something super nice. Now let's add something to the outside of it. Let's add +1. What happened to this graph? Well, it's kind of 2 dots here, but really it moved up 1, right? Which kind of makes sense, right? We're saying y equals x squared, and then y equals x squared was that normal one at 0, and then we said whatever value you get, you just add 1 to it. So it makes sense that everything is just going to move up 1. And you can kind of guess that the rest, if I do add 2, add 3, add 4, it's just going to move up that many units, right? So if I add 4, it's going to move up 4 units. And then, if I subtract, same thing. If I take the value I had and then I subtract 1, it's just going to move down. The y value is just going to move down a unit. So that's going to move down 1, move down 2, 3, and so on, right? So we've kind of learned what happens when we do something to the outside, right? But let's pay attention for a second. We can also do something to the inside of a function. And when I say the inside, I mean, like, we could do f of x. Let's do +1 again. But this time it's in parentheses, like inside with the x, with the squared. And we'll notice this time we didn't move up or down, right? But we moved left and right. And not only that, when we did +1, we moved to the left towards the negatives, right? Maybe let's do +2, so it's sitting on a nice one, right? If we do +2, it's moved to the left 2, which might be kind of weird because we added, right? You'd think adding we would go to the right, but just a little bit of intuition here. This kind of makes sense. Because what happens if we plug -2 in for x, right? Because we have -2 as an x value here. If we plug -2 in for x, we get -2 + 2, which is 0, and 0 squared is 0, and that is the y value here. So that's how it kind of makes sense that we move left. And similarly, a similar thing's going to happen, right? If I add 4, it's going to move to the left 4. If I add 6, it's going to move to the left 6. And if we subtract, same thing's going to happen, except now we're moving right, right? That makes sense because if x is 2, 2 minus 2 is 0. 0 squared is 0, so we've moved this where it would normally be 0 over to the right 2 units, even though we subtracted. And the same thing happens if I do it 4, then we're going to move to the right 4. Minus 6 is going to move to the right 6 for those exact same reasons. And so it's kind of like a good thinking to think if we're in parentheses or with the x, then we are going to be like opposite day, right? But if it's outside, we just pay attention to the positives and negatives. So with that said, we did two things, right? We took the equation f of x equals x squared and we added outside. And we'll notice that when we did that, for this a here, for this a here, what we did is we moved up and down a units, right? If it was +2, we moved up 2. If it was -3, we moved down 3, right? And then for this one, when we had this a in with the x, that constant in with our x, then what we actually did when it was with it, need to get on my marker. When it was with it, we moved left and right a units. But we moved left when a is positive, and we move to the right when a is negative, right? And so the big thing to remember there is if you have parentheses or you are with the x, it is opposite day, right? And so when I think of adding on the inside, I just like to think if it's with the x. And so for our x squared graph, right, that would have looked like x squared plus a if we added outside. But for this one, it would have looked like x plus a in the parentheses all squared, right? So similar things, right? Now let's shift focus back and let's take a look at one of our other paragraphs. Let's take a look at the absolute value of x, right? We have that v again. And the same thing's going to happen, right? If we are on the outside of it, right? If I add 2, if we add 2, then we're going to go up 2, right? If we take any value we had and we just add 2 to it, we're going to move up 2 in the y. Same thing with the negatives, right? If I were to subtract 2, we're going to go down 2. You know, add 6, we're going to go up 6. So kind of same deal, right? But now let's look, if we put something in with the absolute value, notice how it shifts it to the right, right? It shifts left and right. Now that instead of parentheses, we kind of just have absolute value signs. But when we think about it, that's why I like to say with the x, right? Because now it's kind of coupled with this x in here. And now that it's minus 2, it's opposite day and we're moving to the right, right? And it's for the same reasons. Like think of if x is 2, right? Because x is 2 right here. 2 minus 2 would be 0, and the absolute value is 0, and the y value is 0 right there. So that makes sense. And so for here, when we do this, for our absolute value is going to be, when we're talking outside, it's going to be outside those absolute value signs. And when we are talking in with the x, it's going to be in with the x. And when I do x plus a, when I say x plus a, I'm really just saying, let me, if I put a in here, a is just any number, right? And if I move it to the right, if a is big, or I should put plus a. If a is positive, then we're moving to the left. If a is negative, we're moving to the right, right? A just means any value that you choose to put there. So that is all that means. And now let's take a look at one of the other ones we did, right? We had the square root of x. Same kind of thing, right? If I add 2, it's going to move up 2. If I subtract 2, it's going to go down 2. And now if I'm in the square root, so not really in parentheses again, but again, if I'm with the x, if I'm with the x in the square root, if I'm subtracting 4, we're going to move to the right 4, because again, it's opposite day, and that makes sense, right? Because if x is positive 4, 4 minus 4 is going to be 0, square root of 0 is 0, which makes sense, right? And same thing, if I have plus 4, and we move to the left 4, right? If x is negative 4 plus 4 is 0. And so that makes sense there. And so same deal, right? When we come back here, now what we're talking about is now we have the square root of x, and then on the outside would be plus a, and on the inside would be contained in this square root. And we have one more to really look at, and that is going to be our exponential. And we just did 2 to the x because that's a nice one. Oh, that's 2 to the 2. 2 to the x is a nice one, right? And same thing. Outside is just going to be on the end, right? If I add 2, it's going to move everything up 2. And if I subtract 2, it's going to move everything down 2. Right? Same kind of idea. Now, what this one means, if I'm with the x, it's going to mean in with the exponent, right? So if I add 2 with the exponent, or that's not with the exponent, get me up to the exponent. If we add 2 with the exponent, why won't it let me do this? Maybe I need to put it in parentheses. There we go. If I add 2 with the exponent, you'll notice that we've kind of moved over to the left, right? And now if I subtract, it's going to move it to the right. So similarly, that one was a little bit different to think about, but if we have that like 2 to the x plus a would be on the outside, and then what would be considered on the inside would be 2, let me write, 2, and then with the exponent, right? That means with the x. Now, let's go over just a couple examples doing this. Let's remember, if it's outside, not with the x, then we're just going up and down this amount of units. But if it's with the x, right, if we're with the x in parentheses, or it just kind of feels like the x is together with it, then we are going to go left and right that amount of units, and it's going to be opposite day with all of these types of functions, and we might even see an x cubed or a cubed root. So let's just go over some examples in Delta Math. So these are the types of problems you'll see, and what it wants us to do is to translate this function, right? So it gives us, this is our nice function already, right? But it wants us to graph y equals x minus 3 in parentheses squared. And remember, when we had, when it was together in x minus 3, it's opposite day, and we're going left and right. So since we're with the x here, it's opposite day, so I'm actually going to add, I'm going to go to the right 3, right? Or since it's with the x, we're going left and right, and since it's negative, it's opposite day, we're going to the right, so we're just going to slide that whole thing to the right, and we can see where the parent graph was, and now what doing that subtraction by 3 in the parentheses was. And again, you can double check your work on these in a way, right? Because if x is 3, this point right here, if x is 3, 3 minus 3 is 0, 0 squared is 0, so we're going to get y equals 0. So that makes sense, right? Submit that. That one's good. Let's do a different one. It doesn't want to give me. Hold up. Here we go. Okay. So now this is one we haven't looked at, right? But you can kind of guess that the cube root of x is our parent function here, and then we're adding 1. And our addition by 1 isn't in with this cube root, right? So we're going to go up 1, right? So since it's outside, we're going up and down, and we just keep the same sign. So all we do is go up 1, and we can see the ghost of our parent function and our new one that we made, and that one is going to be good. Now, a couple other ones I want to show you. These have 2, right? We're doing 2 and 1, right? So here's our absolute value. This is our original absolute value of x equation or a graph. And now inside with the x, we've gone -4, and that means we're moving left and right, and it's opposite day. So we're actually going to go over 4, right? But then after that on the outside, we have +3, where we're going up and down, and it's just normal, right? So we're going to go up 3. And so here we've done 2 moves in 1. Again, we can see the ghost of our parent function, and now we have our own, and let's check this one, and that one's good, right? Let's go through one more. So here's another quadratic, the ones that we like to see, the ones that we're a little comfortable with. Again, in with the x, right? We're with the x in parentheses. So that means we're moving left and right, and we're subtracting 3, so we're going to move to the right 3. But then after we're done doing that, right, outside of the parentheses, we have -4, and that's up and down. So now we're going to go down 4. And again, we can see the ghosts in our new one. And again, this should kind of make sense when x is 3, positive 3, right? We're going to get 0. 3 minus 3 is 0 squared, -4, so y should be -4. So it kind of makes sense that the vertex is there. That's how I always like to check my work, is I like to plug in a point that I think is going to be nice. Let's check that one, and that one is good. I kind of want to just get one, give me an exponential in here, because we haven't worked with one of those yet. So here we have 2 to the x plus 4. This one is quite nice, right? all we're doing is adding 4 upward. We have nothing with this x, so that means we're going up and down, and it's just the same day, so we're going to move up to 4. And notice how you grab this little green dot, even though it's not on the graph. That just kind of gives you a place to move the entire graph. And we're moving it up to 4, right? And so let's check this one. Where's the submit button? Am I crazy? There's the submit button. I thought there was one up top too. Yep, and that's right. So we've just moved up 4. So it's really just moving up and down and left and right. And when you move left and right, it's opposite day within the x's. I don't think that'll be too harsh on you guys once you get the hang of it. You don't really need to know these graphs yet, but this will also get you used to doing them. And we're going to keep doing different transformations of graphs. So it'll be good to get used to these kinds of graphs.